Hi friends, how are you? I hope you are fine. Lockdown, mask, social distance. 2020 is very boring. Shall we go for a tour? I want to take you to Aero, my hometown. It's not a real tour, it's a physics tour. So that we can understand one of the important lessons in chemistry. Are you ready?
I want to go to Erode from our college. If I am going via Karur, the distance between college to Erode is 200 km. I have started here at 10 am and I have reached Erode at 2 pm. Then what is the speed of my car? How can we calculate? Speed is equal to distance divided by time. Then 200 km divided by 4 hours, that is equal to 50 km per hour. I can go to Erode through Namakkal also. But now the distance between our college to Erode is 300 km. My car speed is 50 km per hour. If I started here at 10 am, then when I will reach the Erode, how can we calculate this? Now 300 km divided by the speed 50, that is equal to 6 hours. I will reach Erode at 4 pm. From this we can understand, if we know the velocity and the distance, we can predict the route of our journey. Suppose suddenly there is a rain at Namakkal while I am travelling to Erode. After reaching Erode, I need to wash my car, right? Why? Due to rain, dirt and mud will deposit on my car. Then my car will become brown at the bottom. So, if I know the situation in the route, we can say the car's condition. In physics, the displacement of particle per unit time is called velocity. In a chemical reaction, the change in the concentration of the species per unit time is called rate of the reaction. In the discussed concept, if we know the velocity and the distance, we can predict the path. Similar way that in a chemical reaction, if we know the rate, we can predict the mechanism. If we know the condition of the route, we can say the status of the car. Similar way that if we know the condition of the mechanism, we can predict the. Here we are taking a reactant A and it is giving the product B. So the reactant, after some time, it will give the product. If we monitor the reaction in different time interval, we can determine the amount of reactant product at each stage. For example, the reaction has been started at 8 am, that time there is no product. At 8:15, 2 moles of the reactant was changed into product. At 8:30, same way 4 moles of product was formed. At 8:45, the reaction was completed. Now the reactant was changed into product. The rate is expressed as change in the concentration of the reactant or product divided by change in time. As we discussed previously, 8 am taken as a T1, 8:15 am taken as a T2. At T1, the concentration of the reactant A1 is 6 and the concentration of the product A1 is 0. At T2, the concentration of the reactant A2 is 4 and the concentration of the product B2 is 2. Now, rate that will be expressed as A2 minus A1 divided by T2 minus T1. Otherwise, we can say that one as a del A by del T. Here we can see that one, there is a negative sign in front of this. So the reason for that one is the A2 minus A1 that will give negative value. Rate always we have to express in a positive value. To bring the positive value, here we are putting the negative sign. Whereas in this case of the product, B2 minus B1 that will give the positive value. So there is no need to put the negative sign in that one. So here we can say that one, the rate of the disappearance of A and the rate of the disappearance of B with respect to the time. So here unit of rate that is equal to mole per time. The time for taken experimental data, rate can be measured using these formulas. So here rate of the disappearance of the reactant that is equal to rate of the formation of the product. So now with this data, if we calculate that one, then here we can see 0.31 moles per minute, that is the rate of the disappearance of the reactant. When you calculate the rate of the formation of the product, that is also 0.13 mole per minute. So now we can understand that one, always the rate of the disappearance of the reactant, that is equal to rate of the formation of the product.